processors that are getting more and more powerful. At the same time, the cost of all these processors are going down, and the kind of things that you can build. It is really difficult to imagine what life is going to be in 10 years' time. So, in my opinion, this is the best time to be alive. Unless you bought Bitcoin earlier this year. Okay, now let me talk about the agenda for the next 45 minutes. I got a lot of things to show you, so I'll try to go fast. So I will give you an introduction of what is machine learning. So this session is mostly catered for those of you who are absolutely new to machine learning. So if you are already an expert, you're already a data scientist, then maybe this session is a little bit easy for you. But what I'll try to do is that I'll explain to you what is machine learning, the different types of machine learning algorithms that you need to understand, so that you can actually better appreciate machine learning. Can I have a show of hands? How many of you actually major in mathematics in university? 1, 2. How about the rest? Computer science? Okay, that's good. How many of you actually hated mathematics in school? Okay, most of you. It can't be you, right? Now, today, if you are really wanting to go into machine learning, a solid foundation in mathematics is really, really important. And if you are good in statistics, then you are born to be a data scientist. Okay? If not, never mind. Stay on for the next 45 minutes. So I'll show you how to go about implementing machine learning. After understanding what is machine learning, how do you actually get started? What is the easiest way to get started? So I'll talk about Python. How many of you are actually Python programmers? Okay, so Python is the next big language that you must learn, whether you hate it or you like it or you feel indifferent to it, but go and learn Python. And there's this particular library called scikit-learn from Google that allows you to actually implement Python without really going through all the nitty-gritty details of implementing the machine learning algorithms. So I'll show you a demo later on. So I'll also show you a very cool tool by Microsoft called Azure Machine Learning Studio that allows you to implement machine learning without writing a single line of code. You just drag and drop and click run, and then that's it. And then you just feed in the data, you can get a prediction. So later on I'll show you a demo of how to actually use the Azure Machine Learning Studio to actually build your machine learning model. And I will also talk about how to use this very, very cool tool called Microsoft Cognitive Services, which is basically a set of APIs that allows you to upload an image to this API, and in return, this API would return you a result. What is the content of this picture? What is the landmark? What is the buildings? Who are the celebrities on this photograph? So it's really, really cool. And one particular feature of this cognitive service is you have this thing called custom vision, where you can actually upload a set of images so that you can train your machine learning models to actually recognize this particular object. And then later on, when you have another picture, you can actually upload and get the cognitive services to tell you whether this picture that you're uploading belongs to this object. And last but not least, I'll show you how to integrate the machine learning and AI into your mobile app. And this is the things that we'll talk about for the next 45 minutes. Left with 40 minutes. So, but if you think that you are too tired to learn anything, at least at the end of this session, you will know what is this. You know what it is?
Durian.
Okay. So if you're not, if you do not know what is this, ask your friend to bring you to, let's say, a supermarket and buy one and try it. So, before we continue, now in the past, if you go to a conference, most talks on machine learning are always dry and boring. It is not that the speaker is not good, but because you have a lot of mathematics, you have a lot of statistics, you have a lot of algorithms. So the end result is that a lot of people feel tired after halfway through the session, and they decided to walk out because they say, enough, I don't want to see all this data and all this code. But and you have tons of charts and figures. But what I can promise you is that for my talk, it's different. It will still be dry and boring. Okay? Now, we still have to go through some of the basics of the machine learning algorithms, although I am not going to go through the mathematics behind them. Okay? So, We still need to talk a little bit about statistics, algorithms, but we are not going to go into the details. What I will focus is that I will focus on how to get started, how to get your hands dirty, and how to see some of the tools available. So I'll show you some demos. So first thing first, what is machine learning? So the formal definition of machine learning is a computer able to learn from experience without being specifically programmed. So, but if you look at it, it's I think an easier way to understand machine learning. It is that you are trying to find patterns in data. So today, a lot of companies, they collect a lot of data. They have tons and tons of data, but they are not aware that they are actually sitting on top of a pile of gold. Because the data that you have, deep within this data is a set of valuable information that you can actually extract using machine learning. Now, a good way to understand machine learning is this. This is what we do traditionally. Traditionally, we have data. We write a program, and we feed the data into the program. We get our output. So that is traditional programming. Now, for machine learning, we take our data, we put in the output that we expect to see, and we get our program. So this is the best way and the easiest way to understand machine learning. So I'm going to show you some demos after this. Now, when we talk about machine learning, two more terms always come into the picture, and that is artificial intelligence, AI. And another term that is always associated with machine learning is called deep learning. Okay, so now what is AI? AI is basically, or rather AI are programs that are able to sense, reason, and adapt. This is what computer scientists are focusing on at this moment. This is what they want to achieve. They want to basically build programs that are intelligent, that can think just like human beings. They can learn from mistakes. They can actually do reasoning with you. So this is what we call artificial intelligence. Now, within the branch of AI, you have machine learning. And in this case, machine learning is basically finding patterns in data. Now, within machine learning, you have another category known as deep learning. So I believe there was a session earlier on TensorFlow Lite. So that's deep learning. So it's a subset of machine learning. It is a multi-layered neural networks that learn from vast amount of data. Now, because we only have 45 minutes, so it doesn't do justice to talk about deep learning in this short session. So we are going to focus more on machine learning in this session. Now, AI, are we there yet? Artificial intelligence, are we, or do we already have machines that are intelligent to think? It's a Boolean answer, yes or no?
Maybe.
No. Okay? Unfortunately or fortunately, if you already have a machine that can think, do you think you still have a job? You know, one day machines will be able to write your code for you. So I think in 10 years' time, you just launch Visual Studio, speak into a microphone, and complete project, and then they will do all the coding. So no, don't laugh. This day will come, and I am pretty confident that it is within our lifetime. Okay, for the next 10, 15 years, this will happen. So there is a saying: if it works, it is not AI. Okay, machine learning. Let's focus on machine learning. So what is machine learning? So it's a collection of algorithms and techniques used to design systems that learn from data. And they have very strong mathematical and statistical basis, but they do not take into account domain knowledge. So basically, you have one set of algorithms that is able to actually accept data and then churn out some useful results for you. Why machine learning? Why is it that everybody now is so engrossed in machine learning? What are the advantages? So it can actually make your apps smarter. So for example, you can actually write a mobile app to take a photograph of an eye. And using that photograph, you can actually upload this to a machine learning model. And that machine learning model can actually help you predict based on the photograph that you have uploaded, what are the illnesses associated with that person? So these are the things that are already happening today. And you can also use machine learning to recommend products that online shoppers may also like. And I think, needless to say, Amazon is the one that first comes to mind when you talk about recommending associated products that people would like to buy. And you can also use this to detect frauds in credit card transactions. Now, in real life, machine learning is already in use. Now, let me give you one concrete example. You guys have mobile phones, right? And the telecommunications company, which we call telcos, usually we call into the telco to make some requests. So there are people who actually make phone calls to the telco to complain and say, your service is really bad. And there are people who actually go and call the telco and say, can I upgrade my service plan, so on and so forth. Now, when you call your telco, before the telco actually answers your call, it detects your phone number. And based on its past data that they have collected from you, they know what kind of customers you are. If you are the nasty type of customer that is always calling in to complain, they will route you to an empowered agent who is able to handle this kind of complaint. But if you are the type of customers that is always very willing to spend more money to upgrade your service plans, they will route you to some best service agent. Okay, so today, companies are already using machine learning to actually best serve their customers. So this is one practical use of machine learning. Now, when we talk about machine learning, we always talk about 5 main types of questions. Well, how can machine learning help me solve the following 5 types of questions? What are they? So, first one. The first one is known as a classification problem. So, classification problem basically means, given a set of data that you have collected, after running through an algorithm on this set of data, you want to be able to predict whether the end result is this or that. So we call this a classification problem. So classification can be a 2-class, can be a multiple class. So it identifies what category that the new information belongs to. Is this A or B? And for example, if you are trying to diagnose whether a tumor is cancerous, you are able to use machine learning to actually classify whether how many percent of this tumor is going to be cancerous and how many percent is non-cancerous. So the classic example of a classification problem is this. And this is a classic example of how machine learning went wrong. Did you realize this? You know, before they announced the president-elect, a lot of people were actually predicting that Hillary will win. Even Donald Trump predicted that he will lose. You know, and he got a shock of his life when they announced that he was the winner. So this is a classic example of machine learning that is not applied properly. Next one, regression. So in regression, you're trying to predict values. So for example, you have a chart. And this kind of chart is pretty familiar to a lot of people. So probably in your university or in your high school mathematics, you learn about this. So you have a set of points. And you realize that set of points, they can actually be lined up using a straight line. And so once you have a straight line plotted, you'll be able to put in a value for x-axis, and you try to predict the value for the y-axis. So this is called linear regression. So in this case, this is a straight line, so this is called a linear regression. So this is a kind of problems that machine learning can help you. So given a set of data, how do you actually predict what is the future value? So this is called a regression problem. So how much, how many? So for example, you can actually predict what will the temperature be like on Monday. And I realized that Monday it snowed, but then when I arrived on Tuesday, no more snow. And you know, I come from a really, really warm country, Singapore, where it's summer throughout the year. So I sort of miss the snow. So you can also use this to predict your sales quarter, your fourth quarter, what is the sales going to be like. So this is regression. So you have classification, we have regression. The next one is what we call clustering. So clustering allows us to discover structure in our data. So for example, I have a series of points here. Now, initially, all the points are not labeled with any color. Just imagine that all the points are gray in color. And you plot them on a chart. And you want to be able to discover, okay, how many clusters are all these points forming? And you want to discover the structure. So this is called clustering. So this is the third type of questions that machine learning can help you solve. So you want to be able to separate similar data points into intuitive groups. You want to ask yourself, how is this organized? And you want to separate the data into natural groups. So that's the third question. Now the fourth question is called the anomaly detection. So you want to be able to find unusual occurrences. So the classic example is your credit card transaction. You want to detect whether a particular transaction is fraudulent. Now the fifth type is called the reinforced learning, where the machine learning algorithm can actually learn from its mistakes, and as time goes by, it gets more and more intelligent. Now, so these are the 5 types of questions that machine learning can answer. So let's talk about the 2 main categories of machine learning algorithms. So when you talk about machine learning, there are always 2 types. The first type is called the supervised learning. And the second type is known as the unsupervised learning. So these 2 terms are always very confusing, especially for beginners who are starting to learn what is machine learning. So let me give you some concrete example to separate the 2 of them. First thing first, let's take a look at this particular data set that you have. So we have a data set containing the square feet of a particular house and its associated selling price. So imagine that you have 10,000 rows of data. And for this particular data set, the first column is what we call the feature. And the second column is what we call the label. The label is the outcome. So when we have this data set, we plot it onto a chart like this. I would be able to actually input a value for the square feet to derive a predicted price for my selling price of my house. So this is supervised learning, where in your data set, you have features plus 1 or more labels, which is your outcome. Now, in contrast to supervised learning, unsupervised learning uses what we call an unlabeled data set. Now, if you ever go to Google and you search for examples of unlabeled data set, sometimes it is really difficult to get a good example of an unlabeled data set. Now, here is what I think is the easiest way to understand what is an unlabeled data set. Take a look at this data set that you have here. So you have your waist length, your waist size, and you have your leg length. So on the internet, there are data sources that allows you to actually get all those values. So later on, I'll show you a demo where I have a data set containing the dimensions, the length of the various body parts of a group of people, 9,000 over people. Now, so in this particular example, I want to plot the waist size, the leg length against the waist size. So when I plot it out, I see that I have this group of points. Now, why is this useful to me? So for example, I am a jeans designer and I want to create jeans of different sizes. So in this case, how do I know what are the sizes that I need to create? So for example, your boss tells you that, hey, I'm going to create jeans of 3 different types of sizes. So what you can do here is that you can actually try to cluster them into 3 distinct groups. And once you have found the 3 distinct groups, you can take the center point of each group, and that is your mean waist size and leg length for each size. So in this case, if I want to make 3 sizes, small, medium, large, I can group them into 3 groups and then get the center point, and I would know what are the sizes, what is the waist size, what's the length of the jeans to create. So that is unsupervised learning. Now, so having talked about supervised learning and unsupervised learning, let's talk about some of the common machine learning algorithms. Okay, are you still following me?
Yep.
Still alive? I told you it's going to be dry and boring, right? So, okay, you're still alive. Now, having talked about the different types of questions that machine learning can answer, the different types of machine learning algorithms, let's talk about some of the common machine learning algorithms that you will encounter. And I can bet with you, some of the algorithms you are already familiar with. First one, linear regression. Linear regression. So probably in high school, you learn about this, you plot the points, and then you try to find a straight line that cuts through most of the points. And interestingly, every time I show this slide, people will actually protest. You look at the two axes here. On the x-axis is your high school GPA, and then on the y-axis is your university GPA. From this chart, it seems to imply that if you do well in high school, you will do well in university. Do you agree? It doesn't matter, you don't have to answer this, right? Okay, now, but data cannot lie. So when you look at this set of data, you say, oh, okay, so we can see that there's a positive relationships between the two axes. So in this case, we can plot a straight line, and based on a particular high school GPA, I can try to project how well the student is going to do in university. So this is called a linear regression algorithm. So there are mathematics involved in finding this straight line. And as I promised, I'm not going to go into the mathematics behind this. Now, next thing, you have linear regression, you have logistic regression. Now, let's take a look at the chart on the left. So it basically plots the income of a group of voters and who they tend to vote for. So as you can see from this very simple example, people who has got lower income tends to vote for Carter. Just an example. Just replace with whichever politicians you want. People who with higher income tends to vote for Reagan. Now, so if you want to solve this problem, you try to predict based on a particular income of a particular voter, who is he or she likely to vote for. Now, if you use linear regression, it looks logical, but then you will get a negative value. If the income of the voter is extremely low, who is he going to vote for? Nobody. Now, to solve this kind of problem, you have what we call logistic regression. So we try to plot what we call a sigmoid curve. So we try to have a curve, an S-shaped curve, that tries to fit all the points nicely. And behind this, you have mathematics involving things like logit functions, sigmoid functions, so on and so forth. So you try to plot a curve that fits all the major points, and when you put in the income of a particular voter, what you get is a value from 0 to 1. Anything that is above 0.5 means that he is likely to vote for Reagan. Anything below 0.5 means that he is likely to vote for Carter. So this is called logistic regression. Now, to test if you are still following me, what kind of problem is logistic regression trying to solve? Remember, I talked about the 5 types of questions. 5 types of answers that machine learning can answer. What kind of classification? This is classification. You are trying to classify whether a voter is going to vote for which candidate. So very good. So you're still alive. Next one, you have what we call SVM, support vector machines. So it's a kind of classification algorithm. So for example, in this chart here, I have 2 axes here. One is the mean daily temperature, and one is the steps per day. And the yellow dots refers to sheep, and the triangle refers to goats. So you have these 2 groups of data, they are labeled, and what you're trying to do here is that you're trying to find a hyperplane, a straight line. It need not necessarily be a straight line, but you try to find a hyperplane that best separates these 2 groups of data. And once you have separated these 2 groups of data, the next time you receive a point with a particular number of steps per day and the mean daily temperature, you would be able to know whether that particular point belongs to a sheep or a goat. So this is called SVM, support vector machines. Next one is called K-means. K-means is a unsupervised learning. So far, all the algorithms that we have talked about, linear, logistic regression, SVM, they are supervised learning. K-means is an unsupervised learning algorithm. So what do I mean by this? Look at the first chart. I have 6 points, unlabeled. So I don't know anything about the 6 points, I just plot them on the chart. And what I want to do is that I want to discover structures. I want to discover how are they related, how are they grouped together. So in this case, I can apply this algorithm called K-means, and I can actually group them into 2 distinct clusters. And once I group them into 2 distinct clusters, I can find their center point, which is what we call centroids. And once we get a centroid, we'll be able to actually do a lot of interesting things. A good example is the genes example that I talked about earlier on. I have a set of data comprising the waist size and leg length, and I can find the number of clusters, the number of different sizes that I want to make. So this is K-means. Now, what I've just touched on is just the surface. If you are really going into a course of machine learning, you have to learn a lot of mathematics, statistics, and you play with a lot of data. So machine learning, to summarize, is difficult. Now, as developers, what we want to do is we really want to use machine learning, but we do not want to implement them. We don't want to go through all the trouble of writing all these algorithms. So implementing machine learning should be left to the people with PhDs, right? How many of you have PhDs in this class? Wow, okay. What does PhD stand for?
Pile higher and deeper.
Huh?
Pile higher and deeper.
Pile higher and deeper. No. PhD stands for permanent head damage. No, I'm joking. So we used to joke about this. It's like people who got PhD, they are so super smart that they study too much that they have permanent head damage. So it's a compliment. So as a developer, we say, hey, just allow me to make use of machine learning. Don't make me go through all the implementation. So, and this is what I'm going to do for the next 15 minutes. So let's talk about how we can implement machine learning. So let me show you the first one, Python demo. Okay, so stay awake. I'm going to show you some code. Now, for those of you who wanted to get started with machine learning, let me just share with you my experience. I think the easiest way is to actually install and download a package called Anaconda. How many of you are familiar with Anaconda? Perfect. So if you download Anaconda, you basically have all the packages that you need to do data science, to do machine learning. Now, this is the first demo that I'm going to show you. What I have here is that I'm going to show you how to do unsupervised learning. And I'm going to show you how I manually implement the K-means machine learning algorithm. So I have a data set stored as a CSV file. What I want to do is that I want to load it up. So I make use of the following packages, NumPy and Pandas. So if you are a Python developer, if you are serious about going into data science, you need to learn NumPy and Pandas. Why do they call this Pandas? There's this package called Pandas. Why do they call this Pandas? Because if you do too much Pandas, your eyes will look like a panda. Serious, it's no joke. It's anyway. So I'm going to load this into a Pandas data frame. So I'm going to load and print out. So there you go. So I have loaded from my CSV file. And the next thing that I want to do is that I want to plot a scatter plot using this library called matplotlib. So right, there you go. So these are my points plotted on a chart. And in this case, I'm going to do some clustering. So Now, if you look at this visually, it is easy for human beings to say that, hey, there are two clusters. There are two clusters. And if you do it manually, you can actually group them, and then you can try to find a middle point for this cluster, for this cluster. But what happens if I say that I want to cluster them into three groups? Three groups. So ask yourself, where are the three groups? If you can spot this, where are the three groups? So for this particular example, there are more than one answer. So what I'm going to do here is that I am trying to assume that the value of k is equal to 3. And what I'm going to do here is that I am going to plot 3 random points. The 3 stars there. And I am going to manually implement the k-means algorithm. Now, because this is a 45-minute session, I'm not going to run through the algorithm, but if you are interested to know, I'll point you to some resources. It's not difficult. And what I'm going to do here is that I'm going to reposition the 3 points so that it can fit nicely into 3 groups. So when I run this, my 3 clusters are shown here. Okay? Now, and then for this, I can actually print out for each point which cluster they belong to. And for those of you who are learning machine learning, this is one good way to actually understand the math and statistics behind this particular machine learning model. But most of us do not have time. We don't want to go through all those things, unless you're trying to do your PhD. Now, the next way would be, hey, Google has got a better way. It comes in the form of a library called sklearn, and we usually call this scikit-learn. So sklearn allows you to actually implement all these machine learning algorithms without really knowing what happens behind the scene. You can simply call the modules that you want, in this case k-means, and I can specify how many clusters I want, the data that I want to fit into this algorithm, and I want it to predict for me how many clusters are there, where are the 3 clusters. So this 4 lines of code allows me to implement k-means, and so let me show it to you. Control Enter. There you go. Are you impressed? Never mind. Okay, so using sklearn, you can actually implement all sorts of machine learning algorithms: linear regression, logistic regression, SVM, decision tree, so on and so forth. One whole huge libraries of machine learning algorithms. Now, so the next one is the one that I have been telling you, one real life use of k-means. Now, I have a data set. Now, the most common question that people ask is that if I want to get a data set, where do I get it from? You can go to this particular website called kaggle.com. Have you heard of Kaggle? Kaggle.com. It has been bought over by Google. Okay, so they have a lot of data set. So this data set called BMXG actually has a collection of lengths of various body parts. So let me just show you. So it has got waist circumferences, leg length, upper leg length, so on and so forth. So what I want to do is that I want to do some data cleaning, clean it, and then I want to plot. So this is the distribution of all the points. So I'm plotting the upper leg length and the waist circumference. So let's say now instead of making jeans, I want to make shorts. So I want to be able to tell my designer, based on this data of live, real human beings, what are the average leg length, upper leg length, and average waist size. So I can specify if I want to make 2 sizes. So I specify k equal to 2, feed it into my algorithm, run it, and I got 2 clusters here. Now, if your designer says, no, I want 4 sizes. So just go in, change to 4, and you got 4 different sizes. And if the company is crazy and they say that he wants 6 sizes, then just change this to 6, and then you get a different result. There you go. Okay, so this is the first demo, using Python and using sklearn. Now, but you may be the type that says, I don't want to write any code. I'm not a coder. So the next one. So you can make use of something called Azure Machine Learning Studio. The good news is that this is free. This is free. Free for most purposes. Usually the word free and Microsoft doesn't go together. But, okay. There you go. This is an example that I have built. So using this example, using this Azure Machine Learning Studio, I would love to actually build this experiment from the start, but because of time constraint. But what I've done here is that I have a classic example, the Titanic. Are you familiar with the Titanic example? Where they have a data set containing 800 over passengers, and they have the various attributes of each passenger, where the gender, how old is she, whether he or she is in the first class, second class, third class cabin, how much she paid for the ticket, so on and so forth, and most importantly, the label is whether that passenger survived or did not survive that disaster. Okay, so using this Machine Learning Studio, what I've done is that I have actually tried to apply. What kind of problem is this? I'm trying to predict whether a particular passenger will survive or not the disaster. So this is known as a classification problem. So I can use the two-class logistic regression algorithm. So the nice thing is that you don't even need to write any line of code. Just drag and drop this algorithm. So it has got one whole classes of algorithms. These are all the algorithms that you can use. Okay? Now, so what I have is that I can try the two-class logistic regression. I can also try the two-class support vector SVM. And I can actually try to evaluate which one is better, which one will give me a better result. So if I've already run this model, I can visualize. And it can tell me the performance of the algorithm. So the blue line here represents the two-class logistic regression algorithm. The red line represents the two-class SVM. So they will tell you the performance. There are certain matrices that you have to look at, area under the curve. To put it simply, the better algorithm will give you a better AUC. So 0.849 and 0.819. So this algorithm is a better one that based on the training of the machine learning model and analysis, they realize that this algorithm is much better. Now, once you're done with this, the really nice thing is that you can actually deploy this machine learning model as a web service. So I'm going to deploy this as a web service. So let me just select this guy and run this as a web service. Okay, let me run this first. Seems like I joked too much. I still got a lot of demos to show you. Okay, now it's still running. Now you look at this thing that's spinning. So if you pay for this service, the moment this spins, you'll hear a Microsoft will hear a sound, kuching, kuching, kuching. This is where they actually bill your credit card. Okay, now once you're done with that, I'm going to deploy this as a web service. And okay, I'm going to deploy this as a web service. Okay, there you go. You see, no coding. This is cool, right? And let me run this, and then I'm going to deploy the web service, and we can test this. I must show you this. This is really cool. Later on, I'll show you where to get the instructions for doing this. I have 2 articles published on Code Magazine. I'll show you the link. Okay, there you go. So I'm going to deploy my web service. So now I'm deploying this as an Azure Machine web service, so that I can write a client application to actually talk to this web service. So, okay, there you go. We are ready to test. So let's test this web service. There you go. So I'm going to enable this, and I'm going to get some sample data. Okay, there you go. So I have one person, one particular passenger. He is in the third class cabin. This is his name. His gender is male. His age is 22. What I can do is that I can try to predict whether he will survive the disaster. Will he survive? No? He will not survive because the score probability is 0.11. If it is more than 0.5, he will survive. Anything below 0.5, he will not survive. Okay? Now, let me show you how unfair life is. In third class, if you are female, will she survive?
Yes. Yes.
Yes? 0.59, she will survive, even though she is in third class. Now, if you are male, if you are in first class, will you survive?
Yes.
Yes. Barely. So what's the moral of this story? Guys, don't go on cruises. Now, why? Now you may say that this machine learning model is useless. Why? Is there a real life usage for this? Yes. Yes. You can use this machine learning model in 4 years' time. Why? Titanic 2 is sailing in 2022. It's exactly modeled after the original Titanic, except that it is made in China. Okay, so let me go back to my slide. I still got one really cool thing to show you. So there you go. So coming to a port near you in 2022. So when the day comes, before you board the ship, please look at my machine learning model and predict whether you'll survive. Now the next thing is what we call Microsoft Cognitive Services. So Microsoft Cognitive Services is a little bit like AI, where you can actually have it is basically a set of REST APIs that allows you to actually connect to it, upload some images and get some results in return. So it has got the following APIs: vision, speech, language, knowledge, search. But I'm going to show you a demo for these three items in the vision APIs, which I think is really, really cool. So you have the computer vision, you have the face, you got the custom vision. So because I'm running out of time, I'm going to rush through. So I have a simulator, so vision API. So I have these two images, and when you upload an image to the vision API, it is able to tell you what is in this picture. It can recognize landmarks, buildings, it can recognize celebrities. So if I click on this, I'm making a REST call to Microsoft Cognitive Services. It tells me that, hey, Eiffel Tower. Okay, what's the confidence? 99.91%. It is pretty confident. And it is able to detect whether this is adult content. Too bad I cannot show you a demo. Next one. Okay, so you will detect Steve Jobs and Mark Zuckerberg. Okay, so I did not really filter the results because I know you guys are developers, you eat code for breakfast, so you like JSON results. So this is the first example. Second one is the face API, which is really, really cool. So I have this example. I can select an image. So I can take a photograph if I want to, but since I'm running on simulator, I'm going to select a photo. I'm going to be very shameless, put in my photograph, and I'm going to try to analyze my face. So it is detecting faces in this picture, and you know the reason why I really love Microsoft Cognitive Services is because it says that I'm 33 years old. And my emotion is happiness. Okay? So now it can also recognize multiple faces. So for example, you got multiple faces, yeah? Choose, detect. Okay? No more JSON. So they will tell you in this picture what are the faces. what are their do they have makeup? What color is their hair, facial hair, gender, age? The only thing that they cannot detect is whether you are rich or you are poor. Okay, so that is Face API. Now the last thing that I want to show you, I hope I have time, computer vision. So where you can actually train and create a machine learning model that allows you to recognize objects. So let me try this. So, and I want to be able to detect food and create project. Okay, so I'm trying to actually train a machine learning model to recognize durians. So I am going to go to this folder. I am going to upload all these images of durians, and I'm going to give them a tag and upload. Now, if you have ever been to a Microsoft conference or whatever, they always shows the examples of hot dogs. I think we are all sick of hot dogs, so I decided to change to durians. It's more localized. Okay? If you don't know what's a durian, come to me after the talk. How does durian smell like? It smells like your socks that have not been washed for 2 months. Now, after you have uploaded the pictures, you want to train them. So you click on train, it will go ahead and train based on all these pictures. And 2 minutes and I'll be done. So it is training. Okay, so it's I think it's moving. Okay, there you go. So it would report back some parameters, precision, recalls, and so forth. And I now can do a quick test. So I'm going to upload a picture to help me see whether this is a durian. So let's say I upload soursop. It tells me that the probability of this being a durian is 3.3. Okay? And if I were to select something else, let's say I select a durian, a real durian. There you go, 95%. Now, once you have trained the model, you can actually export this into a core ML package and put it locally into your iOS application. You can run it locally. You don't have to have reliance on the web. Now, what I have done is that I have created a application that talks to this learning model using REST. And I click on this. I try to ask whether this is a durian. So it says that yes, probability is 99.97. And then if I click this picture, you know what is this, right? Rambutan. Okay, and the probability is 19.08%. Okay, so you can make use of this Microsoft Cognitive Services to actually add intelligence to your mobile app, and there are a lot of things that you can do. And sometimes when you receive a photograph, you don't know what is inside this photograph, you can always upload this to Microsoft Cognitive Services, and then they will come back to you with all the answers. Okay, I think I've run out of time. I'm really sorry. Let me show you the last. So you can get your subscription key from this URL, and then you can access all these APIs through your command line if you want to. And if you want to take note of this, I'll make my slides available, but if you want to look at the examples on Azure Machine Learning Studio and the example on Python scikit-learn, there are 2 articles that I've written for Code Magazine. You can actually get the link from this slide, and then you can actually look at the source code, the descriptions, everything except my jokes. Okay, so thank you very much. I hope this is useful to you. If you have any questions, we can take this offline. Okay, thank you very much.